Dun, 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 dun. Resistors, yes, folks. Today we are going to be talking about resistors. Mr. Young here. I'm going to do a short video about resistors in series and resistors in parallel for those of you who may need a bit of extra support. So, without any further ado, let's get started. So this is my whiteboard. Let's see if we can set this up correctly. Okay. All right. Okay, so first of all, imagine we have an assembly hall here and a canteen here, right? And all the pupils have to get from the assembly hall to the canteen as quickly as possible. Now, a resistor is like an obstacle course for electrons. It's going to slow them down. It's going to make things really difficult for them to move, right? So let's say we have kind of an obstacle course here for the kids, right? So there's nets, there's a pool, there's barbed wire, right? That's going to make it harder for them to get from the assembly hall to the canteen, right? Now, imagine if we had in another resistor, another obstacle course, barbed wire, ramp, swimming pool, mud. It's going to make it even more difficult for pupils to get from assembly hall to the canteen. That's the same as adding a resistor in series. When you add a resistor in series, it makes it harder for the current to travel. It makes it harder for the electrons to get from A to B. All right. Let's say we have a power source here, plus, minus, electrons, 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 OMG, or I should say ohm, my God, there's a resistor here. Let's say that's 10 ohms. That's like an obstacle course. So, total resistance is 10 ohms. Now, imagine I add another resistor here, 10 ohms. That's going to make it twice as difficult for the charges to flow around. So, what is the total resistance? RT equals R1 plus R2 plus dot, dot, dot. This is the formula for resistance in series. So in this case, it would be 10 plus 10 equals 20 ohms. All right, easy peasy, lemon squeezy. That is how we do resistors in series. All right, so what about in parallel, I hear you ask? Well, in parallel, it is a bit more complicated. Well, let's go back to our original analogy. Assembly hall, canteen. Now, let's say we have the corridor, one resistor, or one obstacle course here, okay? Now, pupils have to get from the assembly hall to the canteen. It's going to be a big crush. You've got these nets, you've got barbed wire, you've got muddy pools. It's going to be difficult to get down here, isn't it? But what happens if we add another route for the charges to flow? So basically, I'm adding in this second route with another obstacle course. That's true, but it is a second route for the charges to flow. So are the pupils going to find it easy? Like, are they going to get to the canteen quicker or slower if I add another route? Well, they're going to get there quicker because half of them can go this way, half of them can go that way at the same time. So that's the same with resistance in parallel. Okay? When you add another resistor in parallel, let's see, this is 10 ohms. When I add another resistor here, the charges come along here, plus, minus, electron, electron, electron. Oh, the electrons have two ways to go. Half of them will go this way, half of them will go this way, because the resistors are the same value. So what you're doing by adding this second resistor is you're giving the charges a secondary route to go. Like a traffic jam. The traffic jam here, oh, the police come along and say, oh, you can go that way. Or Google can say, oh, you can go that way. It's a bit faster. It helps to clear the traffic jam. So adding another resistor in parallel actually results in lowering the resistance. Okay? It's going to lower the resistance. Opposite to with a series setup. So what is the total resistance for this? Well, it's the difficult formula, 1 over RT equals 1 over R1 plus 1 over R2 plus dot, dot, dot. All right, now we put the numbers in, you get 1 over 10 plus 1 over 10. Now, if you like fractions, you can keep it as fractions. You may already know that, so they have the same common denominator already, so it's really easy to just add them together. You just add the top numbers. You don't multiply them, you're not multiplying anything just yet. It's just a simple addition. It's 2 tenths. A tenth plus a tenth is 2 tenths, okay? So, is that us finished? 2 tenths ohms? No, you've fallen into the number one pit trap. RT is what we want, not 1 over RT. It's not asking us for the inverse of the total resistance, is it? It's asking us for RT, so we have to flip it upside down again. 10 over 2, which is 5 ohms. Answer. Okay, Bob's your uncle. And the eagle-eyed amongst you will notice that 5 ohms is a half of 10 ohms. And that's a quick resistor and parallel hack you can use if you're doing multiple choice. If 2 resistors are the same and they're in parallel, then the total resistance will be half of one of them. Okay, but that's very rarely going to be the case. And if you're doing this in a paper 2 question in an exam, then definitely write out the formula, substitution, answer with units. That's what you should be doing to get the full 3 marks. Okay, if you're not sure. Now, imagine the numbers are not as tidy as this. Let's say 19 ohms and 18 ohms. Mr. Young, what are you doing to us? Why are you doing this? Why are you making life so difficult? Well, because in an exam, they won't give... It's better to prepare for the worst. Hope for the best, prepare for the worst. Okay? Let's imagine they give you some really nasty numbers in the exam. So we'll put the numbers in. 1 over 18 plus 1 over 19. Now, some of you might hate fractions. Some of you might have had a bad experience with fractions when you were younger. Who knows? But I would look at this and think, oh my God. And I would think, I'm going to use a calculator because I don't want to figure this out in fractions. I'm already out of my depth. So I'm going to take a calculator, right? So this is my own personal calculator. I recommend you get yourself a calculator because you will be familiar with the buttons. And I'm going to show you in a second. Every calculator is different. Not every calculator, but there are different types. So I'm just going to put this into my calculator. 1 divided by 18 equals 0.0555. I'm going to write that down. 0.0556, let's see. And then I'm going to put in 1 over 19. 1 divided by 19 equals 0.0526. 0.0526. Okay, and then I'm going to add those 2 numbers together. So press add. What was the first one again? 0.0556. 0.108. Okay, 0.108. Now remember, this is not the final answer. This is 1 over the final answer. So how do I get this is 1 over RT. How do I get RT? RT equals 1 over 0.108. So I need to 1 over this number. How do I do it with this calculator? Well, there's a couple of ways. If you look closely, you can see a block to the block, or there's a block to the minus 1, block to the power minus 1. That means I can press shift and then this button and then equals, and it should give me the answer, 9.24. 9.24 ohms. That is my final answer for this. And can you see that it is less than either of the resistors? It's an untidy number, but that's the way it is. Life is not always perfect. Okay? So you can use a block to the minus 1 button if you have a Casio FX-85 GT CW. All right? because anything to the power of minus 1 is 1 over that thing. So 1 over x to the minus 1, oops, 1 over x equals x to the minus 1. It's the same. That's one way of doing it. But what if you don't have a square to the minus 1 button? What other options do we have? Well, we could just type in 1 divided by 0.108. Does that give us the same answer? 9.26. Yes, it does. Oh, 9.26. So it's a bit different each time because I've rounded it. Okay, so you could do 1, just do 1 over. That's another way of doing it. Any other ways of doing it? Let's see. ANS. You can use the ANS button on this. So if I go back a few steps and I get this number, 0.108, then I can do 1 divided by ANS, and that gives me another similar answer, 9.26. All right. But what if you don't have this type of calculator? What if you forget your calculator in the exam? All right, let's have a look. How do we use this one? All right, this one doesn't look like it's having a good day, so we'll just put that over there and try this one here. Let's see, AC for on. All right, so we want to find out what 0.108. Does it have a square to the minus 1 button? Can't see one, but I've got 1 over x. That's the same thing. Look, 1 over x. So if I put in the number, 0.108, and then press 1 over x, 9.26. There we go. So you could press this, or 1 over x. There's a 1 over x button on some calculators. All right. Any other ways we could do it? 1 over x. Is there an ANS button? No. There's no ANS button that I can see. But if you do these two numbers, these two calculations, and you get to this, you can just press the 1 over x button. All right, so that's another calculator. Now, what about if you're stuck with this? This does not look like a science calculator, but we can still use it. So say we got to 0.108, 0.108, right? How do we get 1 over this? Or this to the minus 1? Let's see. There's no ANS, but there's m plus. We can add it to the memory. And then 1 divided by memory recall equals 9.26 again. That's another way. Or again, you can just do 1 divided by 0.108 equals 9.26. All right, so these are the different ways that you can get the right answer, 0.108. And they're going to give you different, slightly different variations depending on how much you round it. The first way I did it, I hardly rounded these numbers, but in my later ones, I rounded it a bit more. All right, so just to recap, you have, at the end, you can't just say, this is your answer. You have to invert it or do 1 over. All right, if you're using a calculator, you can use the square to the minus 1 button. You can use x to the minus 1 button. You can use 1 over x button. You can type in 1 divided by the number, or you could do 1 divided by ANS. 1 divided by ANS. Okay? Or you could do m plus to add it to the memory, and then mr to recall the memory in the calculator. All right, so that is how you use a wide variety of calculators to solve your resistance and parallel problem. Remember, resistance in series, you just add them together. It makes sense. It's like 2 obstacle courses for the electrons, okay? If they're in parallel, then you're making it easier for the charges to get around the circuit. You're giving them another route, another corridor, another obstacle course, yes, but another route. If there are 2 resistors in parallel which are the same value, then the total resistance will be half of one of them. If there are 3 resistors which are the same in parallel, then it's a third of one of them, and so on. If in doubt, use the formula 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over 3, dot, dot, dot. Use a calculator if it's a difficult fraction. I'm not gonna work out the lowest common denominator of an 18th and a 19th is going to be. Just use a calculator and use those magic buttons that I showed you. And that is all for today. I hope you found it useful. Good luck with resistors. Take it easy. See you in the next one. Bye.